Hi everybody, this is a video about the ion product of water, also known as Kw. And we know that water ionizes to form H plus OH minus, not very much, but a little bit. And if you want, and notice you have the equilibrium arrows here, so if we wanted to set up an equilibrium constant, it would be the concentration of the products divided by the concentration of reactants. But we know that the concentration of water is a constant, so we like to bring that H2O concentration, which is a constant, over with the Kc. And so group all the constants together, and we call that constant Kw. So Kw equals concentration of H plus OH minus. If you were to write the equation like this, like we did in the previous video, it's like this with water auto-ionizing with itself, we would get, it's the same thing, so Kw is equal to the concentration of H3O plus times concentration of OH minus. We do not include the concentration of water in our equilibrium constant expression. So you often see it like this as well. So at 25 degrees Celsius, Kw is 1.0 times 10 to the minus 14. And a neutral solution is defined as when the concentration of H plus equals the concentration of OH minus. pH 7 is true at 25 degrees Celsius for a neutral solution. If it's acidic, remember pH is going to be less than 7 and the concentration of H plus is going to be greater than the concentration of OH minus. And for a basic solution, the pH is going to be greater than 7 and there's going to be more OH minus. But these pH levels are only true at 25 degrees Celsius. More about that later. Okay, let's turn the page. So, oh darn, I'm just going to erase this. Don't look at it. Close your eyes. Close your eyes. This is left over from last class. But the interesting thing about Kw is that it always has to equal 1 times 10 to the minus 14. So when you add an acid to water, like in this case you're adding HCl, and the hydrogen ion concentration is 1.3 molar. So that means what you've done is you've increased the concentration of H plus to 1.3 molar. In neutral water, the concentration of H plus is 1 times 10 to the negative 7. The concentration of OH minus is 1 times 10 to the negative 7. They have to be equal because water is neutral. Remember, this is the equation here where we have two waters in equilibrium with H3O plus and OH minus. And remember, at 25 degrees Celsius, Kw equals 1 times 10 to the negative 14. And which is equal to the concentration of H3O plus times the concentration of OH minus. Since these two are equal in a neutral solution, that must mean that the concentration of H3O plus would be equal to 1 times 10 to the negative 7. Okay, which is the square root of 1 times 10 to the minus 14. So originally, before we add the acid to the solution, the concentration of H plus is 1 times 10 to the minus 7. But that's insignificant compared to this 1.3 molar. Okay, so what you're doing is you're increasing the amount of H3O plus. In order for Kw to equal to 1 times 10 to the minus 14, so if this one here is 1.3 molar. This one has got to change. The concentration of OH minus has got to change because those two numbers have to multiply together to form 1 times 10 to the minus 14. So how do we figure this out? Kw is equal to the concentration of H plus times the concentration of OH minus. Okay, you can use this format or this format. It's all good. We know that we're trying to figure out the concentration of OH minus. So that's equal to Kw divided by the concentration of H plus, which is equal to 1 times 10 to the negative 14 divided by 1.3. And we put those numbers in our calculator, and we should get 7.7 times 10 to the negative 15 molar. So you can see that if the concentration of, if you fiddle with the concentration of H plus and you increase it to 1.3 molar, then that OH minus concentration has to decrease, and it has. But there's still a little bit of OH minus in an acidic solution, but it's just less than the concentration of H plus, significantly less. Okay, so you should practice these questions here, and it's just about rearranging that equation. It's pretty straightforward. Good luck.